It's really kind of sad that you all are, doing my sound effects. But anyway, so we're going to deal with basic shapes that we've dealt with before in geometry. But I want you to think about just like your basic bathtub, okay? And you've got water going into it somehow. Does the height of the water raise at a constant rate?
No, because the flow of the water is not.
Very good. First off, the fact that I drew this slightly downhill was not a mistake, because the drain would be here and this is sloped downward. Also, the sides of the tub may or may not go straight up. They may have, if you ever ran, this is not, that depends on, think about draining as well. Because the draining, somewhat of the filling, and definitely the draining, depends a lot on gravity, which all of the pipes in your house work on gravity. And so there's a lot of force at first, and then it slows down because there's not as much water for that gravity to be taking hold of. So that is always a little bit tricky to calculate, because you would need, but it's the whole reason why we would need to know the rate. And does it change or does it stay the same?
It changes.
So today, though, for our calculations, our rates are going to stay the same. Okay? Now, also, when we're talking about water systems, let's say we have a conical tank, because that's the first one we're going to talk about right here. But let's say we have a cone-shaped tank, or at least part of it is cone-shaped. As you fill it with water, does this area on top stay the same?
No.
No. In a cone, it would be getting bigger or shrinking as you emptied it. By the way, that's important when you're talking about the chemicals used to treat the water. The surface area actually has more to do with the amount of the measure of chemicals than the entire volume does, because the chemicals are reactive to the air that would be in there. So it's kind of funny, like, a water tank, you're talking math, chemistry, like all kinds of stuff going on there, which is really interesting to me. And yes, these are the type of conversations that I have with my boyfriend on a regular basis. Oh no, Jim might watch this video sometime. Hello, Jim.
His name.
I'd like you to know that I'm talking about your livelihood today. Anyway.
I'm talking about... That's... come into my office. We're going to discuss...
Exactly. Okay, so who does remember the equations associated with a cone?
I think it's like base times height r squared. Is pi in there somewhere?
Pi is definitely in there somewhere because it is a circle.
Well, yeah.
Pi r squared h.
Now, when we're talking about filling the water tank, what we're talking about ultimately is volume. Okay? So, what is the volume of a sphere?
4 pi
No, because that's a sphere.
Anything that comes to a point is 1/3 pi
1/3 pi r squared h.
r squared h. If you remembered that, kudos to you. Or actually, if you remembered any part of that kudos to you. But yeah, that's the volume
I
of...
logic threw it in my head by sticking 3 cones together.
Now, with this formula here, the volume depends on both the radius and the height, right?
Unfortunately.
And the height of the water would depend on both the volume and the radius.
And pi.
And, right, well, pi is constant. So, and by the way, when we differentiate, that's going to get you sometimes. Pi is not a variable. Pi is a number.
Yep.
So the derivative of pi would be 0. Very good. Okay. So here's what we do. Let's see what we know. The top of the tank is 4, and the height is 8, correct? Okay. And the water is going into it at a rate of 2 cubic meters per minute. Okay, meters per minute. And yes, these are in meters. Okay. How fast is the water level rising right when it is 5? I'm going to... So, right when it is 5 meters high. First off, before we go to lunch, if I am doing the water inside, you can't see my beautiful cone I'm drawing, right? Then I'm actually going to redraw this to be 5. Will the radius be 4?
No.
What will the radius be?
A right front. The radius would be.
No. 5.
Wait, no, this isn't, because that's
The rating would be 5/8.
So what we're dealing with is a similar triangle situation here. If this is 4 to 8, then what is this? Right, it's so 2.5, right? And that is what we're going to work with because it's asking us to find the rate of the height of the water at right when it's 5 meters high. So that will ultimately be the cone that we're after there. Does that make sense? We'll continue this when we get back.